The last part of this section is looking at repeating decimals and kind of seeing the characteristics of those. And so first we're reminded 7 over 40 is equal to 0.175. One way again we do that is that recognizing it's a terminating decimal because 40 is 2 cubed times 5, so only those. The other way that we could do that would be the way we did it before is you make that there, and then you want to make it as a power of 100, right? So then you just make this 2 cubed times 5 cubed. So then you have to do 7 times 5 squared, because again, I'm just trying to make them equal. And so then that's where you get your 175 over 1,000, right? That's the other way. The other way is to use long division. Here is demonstrated here. Find out how many times 40 goes into here. It goes into 70 one time. And then you continue on and notice you get a remainder of 0. Now what happens on problems like this here, 6 over 7? Express 6 over 7 as a decimal. And so what we have here is you look at these problems here and notice long division. You continue going, you would go on forever until you end up with this number here, 6, and realize that's the same number I started with here. And so then once you get to a point like that, you know you're done. Your repeated decimals are finished. And so then you're done here and you don't have to go on anymore because you'll know it'll repeat. And so then this decimal will repeat. It'll be a non-terminating repeating decimal. And how do we know that? Here is the rule. When a fraction has a repeating decimal representation that does not terminate, if and only if B has a prime factor other than 2 and 5. So there has to be, again, in simplest form, another prime factor. So this one has 7. So that's why we know it's going to be a non-terminating decimal representation. So keep that in mind as we try to classify repeating, non-terminating, repeating, right? Some decimals repeat. They're non-terminating, but they repeat. Or I'm sorry, the same number like 0.333, but some of them repeat in this form here where they would continue on versus terminating decimals. And then the last piece of this is kind of a classic math question, right? Looking at how do we convert a repeating decimal into a fraction. And so it's a kind of an algebra trick that gets done that you wouldn't think about doing until you see it. And so then you look carefully at this one here, 0.34. What you do is, here's the number trick. Let n equal 0.34. 100n equals 34.34 forever. So these are true statements. This is true. And now that you have two values here that are you can actually do math on them. So what's 100n minus n? That's 99n. Well, let's do the actual 100n with 34.34 forever minus 34 forever. What happens is this cancels out. And so what you're left with is 99n equals 34. And now you solve for n, and you get n equals 34 over 99. And then, though, you then now know that from transitive property that 0.34 forever is equal to 34 over 99. I did another one. What does 0.99 equal, right? Well, let 0.99, right? Let n equal that. Then 100n equals 99.99. 100n minus 1n equals 99n. Subtract that. So then guess what happens? N is equal to 99 over 99, which equals 1. So we've proven, like a famous idea, is that this here, 0.99 forever, is actually equal to 1. And what we learned is every decimal representation and every repeating decimal has a fraction. Again, every fraction has a repeating decimal representation, and every repeating decimal has a fractional representation. So keep that theorem in mind. Let's try another one. I'm going to leave that there for you. Take a look and see what I've done that now. This is a 3 decimal one. Take a look at that. And I have to finish this, sorry. What is n equal to? 123 over 999. So that is equal to that there.